Okay, I'm sharing the screen. Yeah, you can see.
Yes.
Cool. Okay. So this is my repository. Yeah. Today topic will be about stacks and the first program which is based on stacks. So if you know what is stack, stack is just stack is like an array. It contains data in it where the data will be inserted and retrieved. The data is inserted and retrieved in the form of first in, last out. Where if you see the diagram over here, so this is one stack where the data is get pushed inside it, that is called as insertion, and it'll get popped. That means retrieving. So once the data is getting pushed, that will go to the bottom of the stack. Whereas we imagine array as a horizontal data set, but here stack is a vertical data set. That's how we have to imagine it. So if you push it, if at all you're pushing an element, the element will go to the bottom of the stack, and which is the element which has been pushed the last will be the top of the stack. So that's why we call it as last in, first out, and or first in, last out. We can call it anything. So very important thing is that in programming with the stack, if you're dealing with the code part of stack, the main thing is that we are only dealing with one variable which is called as top. The variable top contains the top element of the stack. We don't require any other element, sorry, we don't require any other data except the top element, because we push the top element, we retrieve the top element, we find the size using the top element, we find the peak value using the top element, we find out whether the stack is empty or full using the top element, top variable, sorry. So top is a very main thing, and you deal it only top variable, nothing else. And one more thing is that here, whenever you're dealing with stack, the top variable is assigned with -1 as an index. In the sense, as we see here, the stack indices starts from 0 and so on, whatever the value it is. Whereas we assign a value, the assigned value of top as -1, which is below 0. That means it is out of the stack. And when you assign it, that time it'll newly get incremented to 1, or sorry, to index 0, and then the data will get pushed inside the stack.
Okay.
So from
So
the yeah.
so the top basically indicates if it is
Mhm.
-1, that is an empty stack. If it is 0, then we
Yes,
have at least one element.
yes.
Okay.
So that's what I'm telling. If you want to find out whether it is full stack or it is an empty stack, the value of the top is more than enough. So let's see the code now. So here's the code. So we start with hash include uh, standard IO header file, and we kept a maximum size of 7, which is predefined for now. And int is you can see. Can you see the
Yeah, I
text
can
over
see
here?
this code. Yeah.
Okay, good. So stack, we are implementing the stack in the form of an array here. Since it is told that we should not use pointers in this over here without pointers, so we are making use of array for this. So array capacity is of 7, and top it is globally declared as -1. And here are the following functions. And let's get to the program, and we can go to the functions one by one. So here I'm telling him to push 3, push 5, push 9, push 1, like that, so on. The meaning of this syntax is nothing but we are calling the function push. When you're calling the function push with this particular data, that means that this data is getting pushed inside the stack.
Okay.
The same way, the second element, the third element, the fourth element, and so on. So how is this exactly happening? How is it getting pushed inside the stack? So here, as we see, the pushed function carries one argument, which is the data, which is of the data type integer. So we are asking him whether if it is full, we can't push any of the elements into the stack. Because it is full, we can't push any elements into the stack. So we have to check whether it is full or not. So these functions check whether it is full or not. So if it is full, sorry, here according to this, it is like we are asking if it is not full, then do the certain procedure. What is the procedure? Procedure is like first, whatever the top value is. Initially, the top value is -1, which is predefined. Whatever the top value is, increment the top value. That means if it is -1, it comes to 0. That means the first index of the stack. And the stack top, that means you're indicating this first index. Stack here, according to this, stack is 0. Sorry, top plus 1 is 0. So stack of 0 is nothing but the first index, that means 0th element, and push the data into that. That means you equate the data into that, so it'll get into the place. So I have told push 3. So this is what is going to happen over here. And here it is at the bottom of the stack. So the first data which I pushed will go to the bottom of the stack, as I said. And if it is full, if it is not full, this is what you have to do, so that we can enter the data. If it is full, we can't enter the data, so could not insert data, stack is full. That's what the message will return. So this is how the push operation is working. And here if you see, wait a second, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's keep capacity of 8. Take something. Yeah. So here we have given 9 elements. That means from 0 to 9, 8 elements. That means from 0 to 9 it is. So if you see here, the top element of the stack is 98. According to the data which I have given, the 98 is the last element which I have given. So the top element, that means which is the last element inserted or pushed inside the stack, is 98. That is what is displaying over here. And the capacity of this is 8. Sorry, the index of that element which is stored is 8, and the capacity of the stack is 9. If you count this data, there will be 9 elements which I have pushed over here. So how did we calculate the size of the stack? Very simple. If you go to the size of the stack, if you can imagine a stack, if you can, how should I explain? Okay, I'll try using this. Can you see this diagram? Okay. So here, this is the stack divided like this, and so on till over here. This is -1. This is 0. This is 1. This is 2, and so on till in. Sorry, so until 8.
It is 8.
Yeah, sorry.
Okay.
So until 8. So this is top initially. So here, if you want to find the top of the element, if you want to find the size of the stack, that means you're calculating the indices. How many indices are there? That is the size of the, how many indices are there? Plus 1 of the indices number is the size of the stack. So over here, as I told, return top. After adding all this data, the top value will be over somewhere over here. Am I right?
Yeah.
Yeah. So the index number of this particular block is 8. So if you want to calculate the size of the stack, you just have to mention what is the value of the top. The value of the top gives you the size of the stack. It's as simple as that. And okay, how should I go? Okay, if I go down, let me explain how to pop it. So this is how it is get printed. The size of the stack, whatever capacity is there, the capacity, whatever the size, it'll bring the size, which is 9, and it'll get printed. Now printing all the elements. If you want to print all the following elements, this is the code for that. The very simple code is that we have to use loop for going for iterating through all the elements of the stack. So while it is not empty, why did we give this? Because if it is empty, it doesn't display anything. It's a waste of iterations. If you like, there will be no iterations if the stack is empty. So first we have to check whether it is empty or not. So the first condition is that this is a condition we give. If the stack is not empty, then pop. So here we calling the function of pop. What exactly and how it works? Let's see that. So this is the function for the pop. This is how we define it. Here we declare initialize a variable called data, which will in turn return as the value which you are popping. So here we initialize a data, and then we ask again if it is not empty, then whatever the stack of top. That means this is top, this value is top, and the index number is 8. Index is nothing but the top, and the value inside that will be indicated as stack of top, since the array name is stack, and stack of top, whatever top element is there, that will get into this place, and it will get assigned to the data variable. And then we decrement the top value so that it will come down to it will come one step down, and it will in turn contain the next element which is to be popped and return the data. Any doubts in this?
No doubts about pop. So only one doubt is, if we want to display the values inside an stack, should we have to pop it? Is that the only way, or can we just run a loop through the stack?
We have to pop it.
But it is an
Wait a
array,
second.
right? So maybe we can run just a for loop to iterate through the values. Will that not be fine?
Okay. You're asking me whether we can, instead of popping, we can just directly display it.
Yeah. Can you directly display instead of popping? That is possible.
Yes, we can. Since it's an array, we can do it.
Okay.
I think we need to implement for loop for that.
Yeah.
Yeah. So I think I didn't do that here. No, I didn't do that. We can do that also. There is a possibility of that.
Okay.
So about popping, any doubts? Pushing and popping till now? I'll
No
continue.
doubts.
Okay.
No doubts.
No doubts. Okay. Cool. So this is how popping works. Again, I'll brief this function again. If it is not empty, then whatever value is in the stop, that value gets into the data. That means that will get assigned to the data variable, and the top value should be decremented so that it will it'll point to the next data which is to be popped. And if it is empty, then this will print this message. It is empty. Okay, so that's how the pop function is working. And here what I use while loop as when you're popping it so that will get displayed. It's a simple thing, so I use this. So let me comment this so that I can show you the another one. Okay, I commented it, and let me pop out a single element and display you the size of the table, size of the stack, sorry. So I've called pop element, sorry, pop function once, and it should, I asked to uh, display whatever it's got popped and what's the size of it and what is the index for. So if we run it, you can see here, according to the data, if I pop out one element, that means you're popping out in stack. You can only pop one element at a time. That is that is defined. And when you're popping out, only the top element will get popped out. None of the elements from the middle can be popped. So when you just call pop, this the top data will get popped out. That is the last in, first out. And then the next element is 212. So over here, the top element. So after popping, the top element is 212, and the index number is 7. And now before the stack size is sorry, wait, what do you call it? The index is 8. Now the index is 7. The size of the stack is 7. No, that's wrong. Size of the stack is not 7. It is, sorry, it is this one. The size of the stack should be so much, because since it starts from 0, should be so much. Topless one. Any doubts over here?
No doubts.
Okay. So I've showed you pop. Okay. So as I told, the capacity is 8. That means you can store 9 elements. But here 1, 2, 3, 4, 5, 6, 7, 8, 9 are there, and I've just popped one out. That's why if I ask it if is the stack filled, the message is no, because we have only 8 out of 9 elements. And is the stack empty? No, that's also false. So how did I implement this? Or how should we implement this function? We go top, you can see that. So here is the verification for whether the stack is empty or not. So this is the definition. This is a function definition. It doesn't contain any arguments. The very simple thing is, if the top value is -1, that means if the top value is somewhere out of the stack, that means the stack is empty. Then return 1, else the return 0. That's how you find out whether it's empty or not. And for full, if the top value is max size, whatever size I've given here, which is a predefined size, I gave 8. And if this top value is the same as the size, max size, it is 8, then the top value is over here, the max is over here. That means the stack is full. So that's how you check whether the stack is full or not. So let's see whether if I add another element, sorry, if I don't pop this out, it should display the stack is full since it has all the 9 elements. The stack is full, it displays no. Why does it display no? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are there. If I add another one, okay, there's something wrong over here. It's full.
We did get could not insert data stack is full. The output.
Yeah,
First line.
here it displays, but this one should change, right? The field means it should change to yes. That's what I'm checking for.
Because you're popping once, right? In line number 86.
Oh yeah. Oh yes. But I thought I commented that out. was required. Thank you. So let's see now again. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are there, but it still shows no. Fault. Max size 8. Okay. Index is 8, correct.
Because you're popping out, right? In the while loop, you're popping out the
Yeah.
data.
Correct. Yeah. If I don't display this, then should of course do that. Yes, the stack is filled. Yes, and the stack is not empty. Yeah. Thanks for debugging. So, any doubts over here?
No doubts.
No doubts. Okay. So this all is for the pop. I think I've covered size. I've covered popping. I've covered pushing. I've covered. If it is empty, verification covered. If it's full, verification covered. And peak value of the array, sorry, of the stack is covered all without the pointers. That's the concept of the stack.
Okay. So if in case we wanna like as of now the memory or the stack size is static, basically static or it's fixed,
Yes.
right? So if in
Yes,
case
I
we
have
want to keep it,
predefined it.
yeah. What are the other alternatives to make it more usable? Like something like a dynamic memory or something?
Yeah, you can ask the user to give the data and you can manipulate this data over here. You can just
Okay.
initialize it and then later assign the values, assign whatever the value, scan the input, assign the value inside there.
Okay. Then
And
that
stack whatever maximum size will become. Stack of
okay.
max size. Yeah.
Then will there'll be a changes in the isFull function, right? We'll be passing the parameter maxes.
Which function, sorry?
IsFull to check the size. That'll be taking the maxes as a
Yes. There'll
parameter.
be a change, yes.
Okay, it will take parameter. Right.
Yeah. Nothing.
Okay.
You're just changing these both values over here. If at all you're expecting an input from the user, he'll be inputting over here, which will scan it and direct this as a variable, and this will change. And of course, this should change. So the top value will change. Everything will change again.
Okay.
But this function will remain same for any of the stack, or any of the given value of the stack, any of the dynamic value of the stack. This function is same.
Okay.
So anything else? Any questions?
Yeah. This particular program is clear.
Should I direct you to some line of code?
Sorry, I couldn't. I missed it. I missed all.
Yeah. Should I direct you to should I direct you to some line of code so that you can view that?
No, it's very clear. Very
Okay.
clear.
So
Yeah,
anything?
but as of requirement, it was asked like to create a C library. I guess does that mean that we have to create an header file?
I think so, and I'm not sure about how to do that. So for for
Okay.
meeting is getting started at 6, so I have to do this first. I'll do
Okay.
it. I'll commit the code using that what is it, libraries by
Okay.
today.
And then then we can import that library like including the library, and then we can make use of functions.
Yes.
Okay. Yeah.
Yeah,
So this topic is very clear for me.
good, cool. Okay, so what else is there? That's it for today. These are the topics which we have decided for the meeting. We have successfully did it.
Okay. So where all can you use this concept of stack, this type of memory? last in first out kind of memory
You mean implementation?
implementation. Yeah.
Uh, where else means? Let me think of that. Wait a second. Last, last and last and first out topic. Just a second. I'll just think about that.
Sure. Buddy.
I think I'm not getting any idea about that.
Okay.
Wait. In general, I think stack is used for these things. No, no, no. You have any idea about that? Like, if you have any
Yeah.
implementation, like,
Like basic applications of stack is in what do you say, the parenthesis matching, where we'll give an expression and see whether the parentheses are matching, opening of parentheses and closing of parentheses. Could you recollect? If you have a
okay, you're telling about
complex,
the coding part.
yeah, like basically that's
Okay.
just
Ah,
basic
yeah, yeah.
applications with respect to programming.
Mm-hmm.
That could be
Yes,
one,
yes,
or
yes.
in case of maybe in the memory management in the sense like um, how do you tell that? Using
But
a
memory
stack of
management, it takes like we can take the middle element of the right, like any center element of the stack. We
um,
can retrieve.
okay,
That is
yeah,
the property of
correct.
memory.
You're correct. In case
So,
queues can be used, I guess, for if you're taking into the what do you say processor, the operating system level. That time assigning all the
hmm.
tasks. That time queues are used.
Processes you meant
Yeah, the processes,
operating system
exactly. Operating
processes.
system processes, thread handling, multi-threading, and
Yeah,
all.
correct only. But
That is
these days,
queues.
processes are like queues. Yeah, that's what
Yeah,
queues is a different concept, right? Again,
queues is a different concept. So I was just a bit confused there.
uh, if at all we are using stack concept in memory management of a RAM, random access memory, uh, uh, because in operating systems we knew that whatever process is with a higher priority that will get first executed.
Correct.
So the stack is actually an outdated. I think so. I don't know clearly. It can be used in very small applications.
Yeah. Yeah.
Yeah. So that's what.
That's what. Even I'm also thinking more about stack flow. Where could be used much? Queues. We know that it's been used in this,
It's
like
many things. Yeah.
many things,
In
but
general
queues.
and in computer
Basically,
science
it
also.
queues controls the flow, right? The flow of
Yeah.
data,
Correct. Yes. Yes.
just like a buffer memory.
Version first out. That is FIFO. I think so. Version
Yeah,
first out.
first out, correct. Okay. Yes, so I think stack is clear.
Yeah.
So even we can even use dynamic memory allocation here also, I guess. So that becomes like making use of mallet and all.
Mm-hmm.
Dynamic memory
Yes. Yes.
initialization. Okay. So that time we come across pointers, I believe.
That includes pointers. Yes. I think PTR variables and all.
Mhm. Okay, so I'm very much clear.
Yeah. Okay. Then yeah, we can terminate the
You
meeting
want to
for today.
conclude it? You want to conclude this meeting?
conclude, yes, like we have completed this stack
Okay.
topic today, and we have seen about several functions, but I didn't create a library about this. I've just created a functional code, not a library code. We have understood about stack and from where it starts, like from -1, it starts from -1, the top value, and we can only pop or push a single element at a time in a stack. So, and for retrieving, sorry, for knowing what is the maximum size of the stack, the top value is more than enough. And anything else? Yeah, that's it. Yeah, that's it.
Okay.
Yeah, you can terminate the meeting now.
That was great. Fine. I'll stop the recording.